Well, I'm super excited to kick off our first winter webinar through the Vermont Vegetable and Berry Growers Association with support from the Transition to Organic program, and some of our other webinars are also supported by the Vermont Agency of Agriculture's Clean Water program. Today we're talking about high tunnels, and really grateful to have Jonathan Ebba here from UNH Cooperative Extension and Eric Skovstead from Joe's Brook Farm in Barnet talking about lots of lots of great information. I'm going to stop here and hand it over to you, Jonathan. Thank you so much for jumping in.
Yeah, thanks for having me. So I'm going to start a stopwatch here. I got three things I hope we can talk about today. I want to talk about airflow within the tunnel, airflow out of the tunnel, which we call ventilation, and I'm hoping that we can talk a little bit about humidity. So let's get to it. And if it's okay with you, Becky, I'm perfectly fine with folks coming off mute and interrupting me to ask a question on anything I'm saying.
Great. Sounds good. And I'll keep an eye on the chat and interrupt you if something comes up in there.
Great, thanks. Yeah, so airflow, when we use that word, we're usually talking about inside the house, right? So moving that air around inside the house. We're going to use the word ventilation to mean getting the air out of the house. Um, and the importance of airflow within the house, one of the main things is sort of destratification, right? We can imagine if the air in there is very still, we get a bunch of humidity in one area, we get a bunch of heat in another area. Humidity is staying, around the surface of the leaf. And so by moving that air, we get to kind of jumble all that up and have any given space be more like the average instead of having it be hot up here and cold down here or wet over here and dry over there, right? We're just kind of mixing all that up. So we're distributing heat, humidity, carbon dioxide that the plants are taking in for photosynthesis. The plant's ability to sort of breathe water out of those stomates, that transpiration. There are certain minerals that only move through the plant through transpiration. And so if the plant isn't being able to get water out of those stomates, it's not able to move calcium, it's not able to move boron. And so we can have all the calcium in the world, but if that plant isn't transpiring, it's not able to move the calcium to the actively growing points. And so by keeping that humidity blown away from those leaves, it makes it easier for that plant to transpire. And of course, particularly fungal disease as well, loves to germinate in that really high humidity. So again, as the plant's breathing off and we have a lot of humidity right around the leaf, our airflow strips that away and it makes it harder for our diseases to germinate. We're typically accomplishing that airflow with, we call it HAF, horizontal airflow. People refer to HAF fans. One important thing is that this is not about cooling, right? This is about what I was just talking about. This is about that even distribution. So if someone says, oh, it's so hot in there, and I added a couple more fans, and what they mean is they put in more internal fans to move the air around, that's not necessarily going to reduce the temperature, right? Just because we sit in front of a fan and we feel cooler um, because of I don't have time to explain why right now, but we feel cooler in front of a fan. But it's important to know just you can put all the fans you want inside a house. And if that house is still tight like a drum, we're not cooling, right? So this is all about that airflow and that distribution. So there are obvious benefits to this for disease, humidity, and heat distribution. And I want us to remember we're creating a circuit of air when we use horizontal airflow. Okay, so that looks kind of like this. And that the whole body of air inside the tunnel starts to move in this current. Okay. If we do have a heater, obviously that heat needs to be blowing into that circuit and not trying to fight it, not going opposed to it. When we talk about airflow, when we're talking about ventilation, we're talking about getting air out of the house. And so sometimes our horizontal airflow can start to compete with our ventilation airflow. So in an ideal world, we would be running this horizontal airflow when the furnace is on and the and we're not venting. We'd run it when the furnace is off and we're not venting. but we would not run the horizontal airflow while we are venting in an ideal world. And there are some real life exceptions to that, which we can talk about. So if we're looking at horizontal airflow, we're looking at a certain speed. You can see my little vanometer here. I've got a marking here for HAF minimum and HAF maximum, right? So we want our airspeed to be somewhere between 70 and 200 feet per minute. That's in the ballpark of 1 to 2 miles per hour. What that means for us is, we want a little bit of fluttering in the leaves. They shouldn't be beating, and they also shouldn't be stationary. When we're planning this for our house, we want to do 1/4 of the volume of the greenhouse. So we're saying volumes, that's cubic feet. We can imagine like a foot cube, right? And that much air, all that air in the house up to a level of 8 feet. We want to take 1/4 of that, and we should be able to move that per minute. And this is cubic feet per minute. And when you buy a fan, it should tell you how many cubic feet per minute that fan moves, right? So let's say we take a 30 by 96, and we typically run this calculation to 8 feet. So 30 by 96 has 23,000 cubic feet of air in there. And remember, I want to move 1/4 of that every minute. So that's 6,000 cubic feet per minute is what I want to move. Kind of a rough rule of thumb is that we want 1 pair of fans for every 50 feet of length. So this is roughly 100-foot length. So we would want 2 pairs of fans. I'm going to go back here real fast. So this is the configuration we would want in a 30 by 96, right? 2 pairs of fans, 4 fans. So if we have 4 fans, they each should be rated at 1,500 cubic feet per minute. And that's how we could size the horizontal airflow. Yeah, so we think of some of the catastrophes that are possible in our high tunnels. Snow comes immediately to mind. Drought comes, not irrigating comes immediately to mind. But excess heat, of course, can also be an acute catastrophe. We can imagine the house getting far too hot and hurting and stressing our crop. Sometimes we work with folks who are just starting off growing and they don't think that auto venting is important, or some people don't think venting at all is important. And of course, when we have these pain points and these pinch points where we can have a catastrophe occur in a very short period of time, that kind of should be increasing that motivation for automation, alarms, et cetera, et cetera. So ventilation, really important. The most common way, of course, that we are ventilating in our high tunnels is probably with roll-up sides. These are easy to install. UNH has a video. We start from empty ground to finishing up the roll-up sides on a whole construction of a high tunnel. And we have one video just on roll-up sides. If you're interested in that, just on YouTube, you can do UNH high tunnel construction. We're looking at here this zigzag. These are anti-billow ropes. So these ropes help to prevent the side from flapping out in the wind. We're seeing more and more screening against pests. Of course, if you're screening any of your open spaces, we're going to look at this passive ventilation based upon the open area. And it's just important to note that when we're screening, we're drastically reducing the amount of area that's open. So if you put maybe, let's say, chicken wire on here to keep out woodchucks, I'm totally making these numbers up, we might be decreasing our airflow by 5%, right? But if you put up like a window screen to keep out, I don't know, plant bugs, we might be dropping the area by maybe 50% or more. And if we're putting up something to like blocks thrips or spotted wing Drosophila, we might be removing 80% of the airflow, right? So as we're figuring out how much open area we need to know how much we're impeding that with any screens that we're using. And so the amount of open space here, we can express as a percentage of the floor space. One way of thinking of that is 20. I see 20% of the floor space. I see Vern here. We had a great conversation about this earlier, and we all kind of agree that if we're looking more, the bigger the better, right? And so 35% of the total floor area, that would translate to 5 foot 3 inches of open space on a 30 by 96. So we want to make sure we're getting enough open area that we can affect meaningful air exchanges when it's hot. And I'm not going to go into today how these different airflows work, but if you've got question about trying to design airflow along with HAF and whatnot, please feel free to reach out to Vern or myself or Becky. So here's a kind of a classic question. Do we roll, if we're looking at the roll-up side, this is the greenhouse pipe. Do we roll it up this way or this way? There are advantages and disadvantages to each. The obvious advantage to rolling this way is that it sheds water. Disadvantage here is that like at the couplings or any through bolts or whatnot, if you're going to hit a snag, this one is much more likely to snag on that inside post. So particularly with automation, if folks are using automatic roll-up sides, make sure your attachment is really secure. There are plenty of new really secure ways of attaching this poly to the roll-up that prevent some of the slipping that we used to see in this configuration when the water would sneak in here. But I actually still, for hand rolling, I still do prefer this configuration myself. All right, so that's passive ventilation. What we were talking about is we roll up the sides and we just let the air move through the house. Active ventilation is also an option. If we were, and this is an either or, right? We would not be using this sort of active ventilation and roll up sides at the same time. You might have both in the house, and I'll talk about that in a couple slides. But we're doing one or the other when we are ventilating. If you are going to size for active ventilation only, you need 1 air exchange per minute. Remember, on horizontal airflow, we talked about a quarter of that volume moving if you're actively ventilating in the summer. So for example, a 30 by 96 to 8 feet is 23,000 cubic feet per minute. So to achieve that, we would need 2 typical 36-inch fans to ventilate a 30 by 96. Of course, if we are blowing air out of the house, we need something to let the air back in the house. And this inlet area, we want this to be larger than the surface area of the outlet. So this should be 1.25 times bigger here than the area of the fans that are blowing out. We want about 250 feet per minute is a good flow. So that's higher than the HAF. And one of the big things is where you put this inlet louver, and I've seen them on small houses that are just passive. Like this particular one has a motor, so when the exhaust fan comes on, this motor opens, which will open these louvers. I have seen these, and I've installed them myself, where they're just passive and they're just flapping in the breeze, and the exhaust creates, on a small enough house, the exhaust can create enough static pressure that it'll open up those intake louvers by themselves. One really big thing is that we want to make sure that the intake side, if you have a door that you typically leave open on that house, make sure that intake is on the same side as the door that you want to leave open. Because I'll show you why in a second, but we don't want that fan next to an open door when you're exhausting, because we drop the efficiency of that fan. This is one I'm kind of a fan of, is having roll-up sides with small active exhaust in the peak, right? So if all we're doing is in the wintertime using these fans, when the roll-ups are down and we're not using them anymore, they're maybe covered with snow. I'll talk about winterizing in a minute. When we're not during roll-up season, so in the wintertime, we can still get kind of hot in that house. And if we're growing in that house, it's nice to have a small fan. It can be sized much smaller than the summer exhaust fans with an intake louver on the other side. We can put those up in the peak. And so I could imagine a house that had roll-up sides, this configuration, and does not need this configuration. Right? And so we can imagine a time where we're in the winter and the roll-up sides are down and sealed up, and this is running. And then maybe we get into a roll-up season where the roll-ups are going up and down, and we're using this less or not at all. And then, of course, in the summer, maybe the roll-ups go all the way up and they stay there. If we are winterizing our roll-ups when we stop using them, this sort of baffle that you can see behind here, I like this always. Learned some folks call this a wind panel. So this doesn't move. This is just permanently attached to the structure, and that prevents wind sort of from coming in here, and it helps to prevent some uplift on the roll up, but really it's blocking some of that air inclusion as well. And then we can imagine if we wanted to, in the wintertime when we're no longer rolling up, we could actually put wiggle wire here. We could, I've actually known people that have wiggle wired at the bottom as well. I don't think that's necessary if we have a good roll on the pipe, but we can kind of close this whole thing off. If you have a heated house and you have two layers of poly that are inflated, you think when you lower this down in the wintertime, these two layers are touching and aren't providing any insulation. We can actually remove just one piece. They sell jumpers to do this, but I like to just pull one piece of wiggle wire, and now the inflation from up here can travel down here, and we can actually inflate the sidewall when we're not using those roll-ups anymore. So think a little bit about what our airflow is doing. What do we want our air to be doing? And then how do we not make its job harder, right? So here we see a furnace, and in this, this configuration, tiny house, I have one HAF fan, and you can imagine that what's happening is we're creating this sort of circuit like this, and the furnace is not fighting with the vent. In a typical horizontal airflow, in this case, we have the circuit of air traveling like this. This greenhouse has active ventilation. And so you can see what happens is when I'm venting, my ventilation airflow is competing with my horizontal airflow, and I get sort of some turbulence here, and I'm cutting the efficiency of both of these. If we think about a roll-up side is sort of ventilating this way as the wind creates a negative pressure, or the air movement outside creates a negative pressure here. That air is made up here, and we can think of that ventilation there. And so you can see how, I'll show you in a different slide. If we are doing an exhaust fan here, this is what I was talking about making sure that that open door isn't on the exhaust fan side, because we just end up with this, and we aren't pulling the air from here anymore. Air's lazy, and it's going to take this short route instead of this long route. And likewise with our roll-up sides. This is the one we see sometimes where we're just kind of wasting our electricity. If the exhaust fan is running and we roll up those sides, same deal. The air is sneaking in around here because it's lazy, and it's not being pulled through the house. All right, so I want to talk about humidity. This is a kind of a fun picture. This is actually, we would call this dew, but believe it or not, this is guttation. This is because when I was talking before about transpiration, and that plant is trying to breathe out those stomates to be able to move nutrients through and to keep the water flowing. When it's so humid that they can't do that, some plants actually have these particular structures where they're able to dump water out just to keep that water flowing through their body. So when we go out in the mornings and you walk on the grass and you get your feet wet and you're like, oh, I'm soaked with the dew. There's probably some dew in there, but a lot of what you're seeing is actually guttation. It's not coming out of the sky. It's actually moving through the plant. Super vulnerable for bacterial infection, etc. But it's kind of a cool thing. So what is humidity? Humidity is the water that's in the air, right? The warmer the air is, the more water it's able to hold. We can think of that like with salt, right? So if you have water and you put in salt and you fill it up, and so now no more salt is dissolving. If you put that on the stove and heat it up, you can put more salt in there. Same with the water in the air. If you heat the air up, you can put more water into the air. Um, so in our greenhouses, where's that water coming from? Part of it's just because our air is humid here in the Northeast, but a lot of it is coming from the plant. Plants are amazingly wasteful. Well, plants move a lot of water that they take up through their roots and put out through their leaves, and they haven't used it for photosynthesis or anything, just to keep that water flowing. It's coming off the soil from our irrigation, et cetera, when we irrigate, and that soil is evaporating water. So we're putting water into the air in our tunnels, right? So we can imagine here, the yellow circle is how much water could be held by all the air in the tunnel. Okay, so if we have nice hot air, let's say, I'm just making this number up, let's say that the high tunnel could hold 100 pounds of water because it's nice and warm, right? Remember, the hotter it is, the more it can hold. And now let's say our plants and our irrigation put 20 pounds of water. That's completely reasonable that we would have 20 pounds of water dissolved in the air in our greenhouse, right? So we could hold 100, we're holding 20. Now, what happens as the sun goes down and our temperature starts to fall, right? So now our temperature is down to 70 degrees and the air can only hold 60 pounds of water. But what? There's still 20 pounds in there. We're assuming that the plants have stopped transpiring, which isn't true. I mean, of course, there might actually be 22 pounds at this point, but just for the sake of this illustration, keep it the same, right? So now that air can only hold 60 and it still has the 20 because that water hasn't gone anywhere. Now let's make that house even colder. Now that house is at 60. Let's say the air could hold 30 pounds of water, still got 20, right? So in this scenario, what happens at 55 degrees or what happens at 50 degrees as we get even colder? Maybe the air can hold 15 pounds of water and 5 pounds of water are going to come out of the air. And that's going to be condensation. And we know we tend to see that localized in different areas in our houses, but that's where we have this really high relative humidity, right? So this is a high relative humidity. This is a low relative humidity. And so our plants are going to have a really hard time transpiring. And yeah, and our fungi are going to love it, et cetera. And at 55 or 50 in this scenario, we're going to end up actually with free water on surfaces. All right, so what's one of the ways, so just conceptually that we can deal with that? So here we are, that's the same greenhouse that I just showed. This is a greenhouse that's 60 degrees Fahrenheit and it's got 20 pounds of water in there, very, very high humidity. What if we run the vents, right? So now we're bringing colder air. So now the yellow circle is even smaller. But by running those vents, I have pushed all this water to the outside. And there's still a little bit of water in the air outside, but the air outside tends to be certainly drier than inside our tunnel, right? So now I can hold even less water, but I got rid of all this water and I'm bringing in just a little bit more water for now. Of course, the plants are going to add to this, but now here's the magic. What happens when I heat that air up, right? So now I bring it up to 70. I've got that capacity. I think we said to hold 60 pounds, but I still might have only the 5 pounds that I brought in from the outside. So this is how we get that low humidity, right? We got to push out the hot, wet air, bring in cold, dry air, and then turn it into hot, dry air. And we know that when I talked about calcium, particularly, this is a calcium deficiency, that if you have enough calcium in the soil, but the air is not moving and the plant can't transpire, you will get this calcium deficiency. And I'm going to skip through this, but we know too that downy mildew on spinach, leaf mold on tomato, and powdery mildew on tomato, that those are all exacerbated by humidity. So thank you. Thanks for letting me get my little humidity talk in there too.
That's great. And those last couple photos make me not want to start growing anything again. It's like, does anyone have questions for Jonathan before we move into Eric's going to cover some practical farmer strategies for managing some of these things? So Can okay.
Yeah, I have one. It's
Well,
Vern.
yeah.
Um, what do you suggest for visualizing, monitoring airflow in greenhouses? Um, I have been looking around at this. There's some expensive uh, smoke test things, but also incense sticks are recommended by some. Have you ever tried that to just see where the air is flowing in a tunnel?
No, nope. I usually go out and I'll just map it with my
Your
vein.
fancy pantsy tool there, yeah.
Yeah, it's that's actually a pretty primitive tool, but yeah, that's and I just sort of create a map and then I can use
Uh,
Excel to color code that. Have you been doing smoke work? And I think
No,
Becky and I were
it's
talking
just,
about
I've talked about it. I've never done it. It just occurred to me it would be pretty cool, but you worry about toxic things. And some of these smoke kits, can't tell what's in them, but it seems like an incense stick might be a pretty low cost way to take a first stab at, especially when I just wonder about, you have the passive roll ups and you're running the HAF. Where is the air going? That's just kind of a confusing thing. So I'm going to be stopping by your farms with incense this summer. I'm the best smelling farm visit you ever had.
We'll just call you Patchouli Vern. Um, there's a question from Tasha asking about combating humidity in non-heated high tunnels, which I think Eric might be touching on too, but if you have any thoughts quickly, Jonathan.
yeah, just in terms of getting that out. Like we tend to be thinking about closing those tunnels up at exactly the wrong time, of course, as the temperature is about to drop. And so we're trapping in all this moisture on the falling temp, and that's going to give us those humidity issues. So whatever we can do to get that water out of the house, and then maybe even so I won't say that. We want to get that water out of the house. It's much easier when we can heat, um, but if we can't, keep that vented as long as possible.
Great, thank you.
That's good.
Eric, why don't you go ahead and
Right. So I'm Eric Skofsted from Joe's Brook Farm. We grow in two locations. Well, now four locations. Three of them have high tunnels, and we've started with really simple 21 by 48 ledgewood tunnels, and we built larger ones like this over the years. This is a 196 by 30-foot ledgewood tunnel. And so we've done a lot of different stuff, and we still do a lot of different stuff. There isn't a best way to do it. This tunnel was built in 22, I think, maybe 23, I think 22, and it has a ridge vent, which was a first for us, and I'll talk about that. So some high-tech things like a ridge vent, but then some low-tech things like some recycled barn doors that I pulled off of a barn project. This is a tunnel we bought used. It's a company that I don't know if exists anymore. It was a Four Seasons tunnel, Four Seasons tools. It is a moving greenhouse, which we used to have three of. Now we only have one of them. One is plenty when it comes to moving greenhouses. This is a tunnel with heat. Sometimes, if we decide to hook it up, you can see the heater hanging in the back of the tunnel. It has very cheap manual open not ridge vents, end vents, gable vents, I guess they should be called, gable vents. And then it has the most basic form of automatic roll-up sides. And so that's just an example of how you can kind of start to automate your tunnels incrementally, with just the sides first. Thinking a little bit about how you automate if you've never done that before. It's great. We started automating our greenhouses in 2019. It's really daunting at first. There's a lot of different products and different suppliers, and it is a large expense, but it's well worth it. At its most basic, if you're just trying to get your sides up, you're not, and maybe with the option to run a heater, you can get into it for, well, 2 motors for $318 off of the Nolts catalog, and a basic controller for $820. And you'll be able to control a heater, even a fan, and your sides with that. You want to start to regulate humidity, which is really nice. Then you're talking about a whole nother level of sensors and controls. But if you are going into this BIOS, the best place to buy it is from Nolts, especially if you get some early season pre-buy discounts. Advancing Alternatives has really changed a lot in the last since we've been buying their stuff in 2019. They're a great company, but they're constantly sort of like evolving how well their controllers work, and they have great technical support. Recommend their stuff. I just put these in for shock value, but to kind of show, like, it was just photos I happened to have. Here you see just a very basic type of gable vent paired with automatic sides. And then this is kind of the hardware on the bottom middle. That's you see the 2 levers, kind of boards sticking out of the gable end, with my daughter in the middle there. Those are what you're talking about when it comes to rolling up your sides. That's all you have to install. I just put these in there to show kind of how durable the automatic sides are. Like, they can survive this one, they happen to be up, and I always put the controller above what I think the potential flood line would be. And so it's survived several floods. And then this ice event, the controllers were down, and they survived the motors were down, the controllers mounted higher, and they survived just fine. So we started building a ridge vent in 2019. We'd farmed for, I don't know, 10 years before that without ridge vents, and we were doing fine. So I'm not sure why I thought we needed this technology, but it's something that always made a lot of sense to me. And with the bigger houses that we were building, it was becoming increasingly, like, kind of difficult to really vent them properly from the gables. So I thought, let's try a ridge vent. We had NRCS money for the greenhouse, so I thought, I'll just do the ridge vent myself and pay for it ourselves, and didn't really know what I was getting into. That was in 2022, and basically it takes about as long to build the ridge vent as it does the rest of the greenhouse. A few tricks. It's just a lot of kind of on-site fabrication. I don't think that would change whoever you bought it from. We were adapting a Rimmel ridge vent to a Ledgewood house. I like to build Ledgewood greenhouses if I can, and that was no trouble. Ledgewood doesn't offer ridge vents just because they are complicated, and so it's a lot of kind of on-site fabrication of just stock components, a lot more measuring and assembling, and it's all up super high. So related to that, for any greenhouse, we always sort of use, when we build it, we use a truck. You can see the truck down below with a ladder rack, full set of staging on top of it. That's a nice moving platform. With 3 guys, you can get a lot done that way. And then we kind of carry about 100 2x10s on the farm at any given time. And those are great staging for things like working on a ridge vent. Since I built this ridge vent, there was some Inflation Act money through NRCS that they were giving to people for ridge vents and automatic controllers. So that's something you should look into. Basically, if you're curious about building a ridge vent, you kind of have to think about it as 2 phases. The first is you just build the hinge, and you have now a break in your greenhouse plastic. So you're going to need to have 2 lengths of wiggle wire to kind of accommodate that break in the plastic. And then you'll build that first, and that's where we're at right now. And then there's also like in this photo, Then there's a rack and pinion system of gears and a drive shaft and a motor very similar to the one that you use to roll up the sides automatically that can be installed. This was just me not realizing what I was getting into, and the day before the crew left for the year, trying to get plastic on the greenhouse before we'd had a chance to finish the ridge vent. So there's no drive shaft. So the only way to put the plastic on is to kind of do one side first, the up and over, and then open it, and then do the side that you see here that doesn't have plastic on it. But I hadn't built the drive shaft yet, so I had to like wedge it open with 2x4s. Anyway, don't do it that way. Make sure you get the drive shaft done before you try and hang the plastic. So we built a couple of these 200-foot long greenhouses on our farm, and I think it's probably too long. I don't know if I'd recommend that. There's issues with maybe harvesting efficiency, just size, weight of the plastic when you go to reskin. We did it a couple times now because it just fit the site. And then I actually built this one, and with the first one, we built this one, and then I kind of forgot why we built it 200 feet the last time. So I just did it again. I was like, oh yeah, it was just because it was the right size for that site. But a little bit shorter, maybe 125, 130 I think might be the sweet spot, honestly. So that's where a ridge vent is kind of nice, because it takes the size of the plastic that you have to put on the house and kind of cuts it almost in half. So the actual weight of that roll isn't as much to manage. And we find it it's easy to kind of pull it over this way with ropes. And again, we're just bringing this 2 layers of plastic up to the ridge and just over, and that's where it'll go up and down. Here's what happens when you try and this is a 200-foot house without a ridge vent, and is the plastic's just too heavy. No matter what you do, that continuous 50-foot sheet by 200, if you pull it over with ropes, there's a good chance you're going to burn the rope burn into some of your plastic, and that's why I'm up there trying to tape the plastic. So this is that house with the ridge vent. It's a 200-foot house. We also have started in our larger houses. We do the circulation fans. It's about 50 feet apart, and this house doesn't have heaters yet. It will eventually. We just haven't gotten around to it. Those circulation fans are great. I think you can see they're probably off right now, and we do use them a lot. And this house is netted, and it certainly does reduce the ventilation a ton. The ridge vent is not netted. I couldn't figure out how to do that. It's kind of one of those fudgy spots. But I do think just netting the sides keeps a lot of the bugs out of there. That could be problems. And this Cheryl did a study. That's what all those flags are. It's a multi-year study, and she's looking at beneficials and pest pressure. And even with these sites, this is in a field where we've grown cucumbers for forever. So there's definitely pressure, but that netting kept it down, even though the ridge vent wasn't netted. And so this is that crop probably just a couple weeks later, honestly. And even with the ridge vent and the circulation fans, it just works out better for us to pick first thing in the morning in this house, because it still gets too hot with that netting on the sides. And the guy's picking full rain gear because it's just, the plants are just absolutely dripping, not with dew, but with whatever Jonathan was talking about. I don't know if there's anything you can do about the cucumber situation and the amount of moisture on them when you're netting it, but you certainly can, even with a bunch of circulation fans, but you certainly can manage moisture with these, like this type of a crop. And you kind of like think about it right now, is when you want those fans on, and make sure you're just keeping the base, everything as all the air around the surface of the soil moving, and around the plant moving while you can, because eventually it'll look like the next slide, and then you really won't be able to manage anything. This is actually a different greenhouse, and the lettuce is probably planted too close and maybe was allowed to get too big. We're looking at it in November now, or late October. That's what this planting would be. But I think it helps to have those circulation fans on early in the season, even when you don't think you need them on a crop like this. But anyway, just an observation. All these greenhouses have automatic controls for the roll-ups, the heaters, and either a ridge vent or gable vents. These larger greenhouses that we have. So that would be the Aegis Tech controller. We don't have automatic controllers on the circulation fans. Sort of just run those or not run those depending on the cycle, the time of year, and what we're thinking. But we're not scientific about setting those controls. I think I would say that we probably create about 3 different environments over the course of a crop with our automatic controls. And we're thinking about humidity, in the greenhouse, temperature. So one of the things that I think matters almost as much as how you set the controls is how and when you irrigate, and also your soil type. It's a huge variable. So we sort of experiment with sometimes trying to soak the soil a lot in the early morning or something, and then let it dry out over the course of the day for a week and try and get it real dry in there, and then soak it again once more. I'm not sure. For crops like lettuce, maybe that's appropriate. It's not great probably for your cucumbers and your tomatoes. That doesn't work at all. You have to do a more even irrigations. I don't have a good sense of the cost of running those circulation fans. I feel like it is a bit more significant than the roll-up sides. The roll-up sides are kind of insignificant in terms of electricity usage, but those circulation fans, depending on what you have, seem to cost, I don't know, maybe $50, $75 a month in a large house, total. That would be my very ballpark guesstimate, just from looking at utility bills and trying to remember if I had the fans on or off that month. I think a really great project would be some sort of laminated crop specific sheet. Could have the VVBGA logo on it. Could be like a binder. It could just be I don't know. Basically, it would live in the greenhouse, and it would kind of have different scenarios for different crops. And it would kind of give you an idea of what to actually set your parameters at. So like what time of day you would set your differential setting. You can create there's a lot of complexity with some of these controllers. So you can create different environments even at different time of days. So like what temperature you would want the heaters to kick on, what humidity you might want them to kick on at, what humidity you might want the sides to then roll up at, and on it would go, based on the stage of the crop. Could be pretty helpful. We are just guessing most of the time, kind of going on experience, but it's more of an art than a science.
Hey, Eric.
Yeah.
I'll share a question that came in the chat, question and a comment. It says we usually turn the circulation fans on and just keep them on for the whole season. We don't have control on them other than a light switch. Could they be turned off in the night or some other scenario? Punt that to you, Eric, and Jonathan as well. What do you do?
Those circulation fans, we tend to just leave on. I agree with that. Let's see. So, just basically with if you're going to go with automation, just know that there is going to be stuff that goes wrong, and it does have to be fixed pretty quickly. A very common phrase on our farm is like, "Oh, I think the side is broken." Eric, go fix that. So that has to happen, and it has to happen quickly. So visual, but also remote monitoring, either through Monit or a Sensaphone, is great. And kind of like Jonathan was saying, a too hot house seems to be a much bigger concern even with automatic controls, than a too cold house. It's just happens quicker during a time of day when you're not around, when you're in the field doing other stuff, harvesting, versus a too cold house, like when the side's not going down. And it's at a time of day where you're able to deal with it better and have a little bit more time to kind of manage that problem. So we always kind of keep the T handles on the other side of the greenhouse from when we do the roll up sides, so that in a pinch you can do it manually. But we also stock an extra motor on the farm if we need, to use that, and then extra relays for the controls. And this is all stuff we've just learned from Advancing Alternatives, because they are great to get them on the phone and they'll help you sort through problems and broken stuff. Uh, Again, multiple mechanisms are really great for cooling. Like, so that's where if the roll up sides are broken, maybe the ridge vent still works, or maybe the gable vent still works. So you can just kind of get by that way. And then one of the funniest things only with about roll up sides that we never expected would happen with our automatic roll up sides is sometimes you can catch an animal in the greenhouse if the sides happen to go up and then go back down while the animal's in there stealing a cucumber, for example. So anyway, that's my presentation. I can take questions.
Thanks, Eric. That's all super helpful. So many lessons learned there. I see a couple things in the chat here I can start throwing at you too. Adam says we usually turn on circulation fans and just keep them on for the whole season. We don't have controls other than a light switch. Could they be turned off in the night or some other scenario? Oh, Jonathan, you wrote back. Keep them on at night. Great.
Yeah, for me, ideal, in this magical world where electricity was free or whatever, I would run HAF every single instant that I was not ventilating. And then again, in this ideal world, my ventilation is super effective and I'm not worried about air getting stuck in the peak or whatever. I would not run HAF when I was ventilating. That's all. They're two entirely, and this speaks a little bit to Daniel's question as well. Circulation is different than ventilation. They're two entirely different things. So yes, there's an advantage to having circulation fans, no matter what kind of ventilation you have, but they shouldn't be running during your ventilation in an ideal world, whatever kind of ventilation you have.
So I actually had a, a related question to that. Like with a really thick crop canopy, like a thick tomato or cucumber crop, um, would you like, is the advantage of mixing that air even with ventilation open a thing? Like, what do you think?
Yeah, so again, ideally you would have your ventilation airflow, which whatever your ventilation configuration is, whether it's active or roll up sides or ridge with a side vent, whatever it is, there's some airflow there that is maximized when it's not being disturbed. So ideally you would not have the circulation while the ventilation was occurring. However, life isn't perfect and our ventilations aren't perfect. And so there are certainly times when I could imagine you have your roll-up sides up, and then you've got all this hot, humid air stuck in the peak, and maybe very little wind, very little breeze, airflow, air movement outside. And even though turning on your horizontal airflow at that point is going to cut the efficiency of the ventilation, it still might be advantageous to get that mixing to get some of that heat out of the house. So those would be sort of exceptions to the theoretical ideal. And one thing I will say too for Eric, when Eric, you were talking about folks getting rained on from the guttation in the cucumber house, um, a long, long time ago, there people used to use turbulators in the greenhouses, and they're essentially like imagine like a ceiling fan where you're pushing the air out of the peak and then down and around. And then that got replaced over time, particularly in the ornamentals greenhouse world, where Vern referenced John Bartok earlier, did research to see that that sort of horizontal that I was talking about really is a more effective way of moving air than creating all this turbulence and turbulation to bring the top down. However, that work was being done sort of in the conventional benched greenhouse world. And we're seeing now more and more, even in high-tech hydroponic greenhouses on vine crops, those old turbulators are coming back. And it might be that this sort of an airflow, um, when we're dealing with floor-to-ceiling vines, might be more effective than the horizontal.
We have a couple of those in Jonathan, the vertical airflow fans. Is that kind of the newer version of that?
Yes, yes.
Yeah, and been quite happy. We just have like two in a 100-foot greenhouse. And I think theoretically, like it makes sense in those when the thick canopy is there to have the air moving that way. But
Yeah. So I wonder if Eric's crew would be drier with that configuration.
Yeah, maybe they would. I think it has just more to do with the the netting. That stuff is just incredibly prohibitive to cooling. I mean, ventilation, you know. Um, no matter how many fans you put in there, it just seems like the cucumbers are growing so rapidly that it's
I think this came up at the High Tunnel conference that if you're screening for large insects and using what's sold as insect netting, that it may be too fine of a netting or finer than you need, and you're restricting airflow more than you need to. You know, if they're designed to keep thrips or spotted wing out, it's going to
yeah.
block a lot more air. I put a fact sheet that gave some guidance on how much air is blocked based on the mesh size. Eric, I did want to ask you because you commented when I saw you this year about some issues that you can have with the automatic roll-up side motors and how to avoid those problems.
Uh yeah, I mean, one of the one of the worst things you can do is if it is install it upside down. Um, make sure the motors look interchangeable top to bottom, but you just have to follow the instructions carefully because there's a weep hole that will let condensation out, or if there's a flood or whatever, or just being buried in snow all winter. Um, we've had one fail because it got flipped around and the weep hole was on the top. Um, other things that go wrong, just hitting them with the wires with a weed whacker. That's really the main problems we have. We sort of have bolts that shear on our 200-foot houses that are actually in the pipe, but that's sort of more of an engineering problem. Maybe that system of tapped screws and bolts isn't between each piece of pipe isn't actually rated for a 200-foot long pipe, but that's a different problem. But we really haven't had too many problems with them other than that.
and Adam put something in the chat that I've also heard from Benner that he works with about the relays and the advancing alternatives controllers, and I think they just keep a bunch of parts in stock because they do seem to be needing replacement every year. So I don't know if other people have had that issue.
Yes, we have that issue all the time. And there's often Advancing Alternatives is a funny company. They're really great on the tech support, but they are definitely evolving their technology all the time. And they've had some big screw ups that they quickly fix. But we had a controller with the touch screen had silicone that wasn't rated for the heat or something, and it went like oozed onto the touch screen, so it acted like it was always touching. That wasn't helpful, so it didn't work. They replaced that. They sent one once with a 5 amp fuse to control the ridge vent instead of a 10 amp fuse. That's a big difference. So the ridge vent didn't work, but they fixed it immediately. So once we let them know, but it's very frustrating when you're like, I don't know what's wrong. Just call them. They can get through it pretty quickly. And then, of course, the relays, we swap them out all the time.
That's a helpful tip. Thank you guys. And Adam also said he's welded their roll-up pipes so they don't have any more bolts.
Yep.
I don't know if you want to elaborate on that, Adam, but that's helpful. Huge thanks to our presenters today. And what a wealth of information. And thank you guys. And
Thank you so much. Thanks for
yeah.
having me.
And next week,
great to be here.
more on the high tunnel theme. We have hot tips from growers, innovations. So stay tuned. And yes, thank you, Jonathan. Thank you, Eric. Have a great rest of everybody's day.
For sure. Thank you. Bye.
Thanks.
Thanks.